fantastic. It's having a purpose.
Yeah, I'm soon going to ask on LinkedIn, and I might even announce it here, that I will be looking for a few people to help me out to review some chapters. I did that for an article once, and I had up to like, I don't know, 10, 20, 30 people joining in the same Word document from OneDrive. And then you had 20 people putting comment on one article, and it was amazing. It worked really well. And I want to do the same with the book, asking for like 10 or 15 people to review each chapter.
Smart. Crowdsourcing for free.
Yeah, but I really believe in the idea that if you bring different people, like really different people that I don't even know, right? And they all see the chapter and they ask different questions and make different remarks. Even like someone that just see the file and just makes one remark, it can be really insightful and really help me to see, okay, this person didn't get it. It means that, well, I need to change this sentence, or I need to change a picture, and you know, just this small remark really helps me to understand what people see that I could not see or that I could not explain properly.
Just a heads up, I think that's your file, Josh or Naja, but it's on the screen. Huh?
Oh, that is?
Yeah.
Yeah, Josh, it might be that you're sharing your screen rather than just the...
Yeah, all right.
But definitely, Jan, if you have ideas, I can only advise you, like I'm advising anyone on earth, write a book. It's an amazing process. I really do enjoy it. It takes time, obviously, but like any hobby, it just takes time, and it's amazing to do such a thing.
Well done. That's great. That's great achievement. That you've written two. You're writing a third now. Right?
Yeah.
Amazing. Well done.
And well, before I started to write stuff, like in 2017, for example, I would never see myself as someone who was able to write anything, especially in English, which is not my native language, obviously. But even in French, I was really like, I cannot write. So.
We see people are joining the webinar, so just want everybody to get in, and we'll give it, you know, a couple minutes after the hour to get rolling, to let everybody get in.
So I'm guessing they can't hear what we're saying now, right?
Yeah, they can. Pretty sure. We're live.
Yeah, great. Hello, everyone. I hope you also have a sunny, good weather wherever you are. Here in Belgium, it's definitely spring now, so I'm enjoying the weather. And I see some familiar name. Hello, I see Mario is there. Hello, Mario.
And Benjamin with great weather in Germany. Fantastic. Like South Africa, Cape Town. Sun shining here.
Yeah, great. We have people from all around the world. It's wonderful.
Johannesburg, great. Ilse. Toronto, the land of Ryan Reynolds.
Hello, Larsen. It's great to see you as well.
Even Moscow. Hi, Tatiana. That would be interesting, Benjamin, to see where everybody's from.
We'll give it just another minute before we get rolling.
Another Johannesburger. Nice.
It's a lot of people from South Africa, Germany, and Canada, it seems.
And Minnesota. Ah, thanks, Johan.
All right. A couple minutes past the hour. We have yet another very global group here, so this will be great, and we will make this very much a conversation.
You still see your screen, so maybe you need to share it differently.
Oh. You don't see the PowerPoint?
Here we just see the PowerPoint. Yeah, sorry for interrupting you.
Okay. Hold on there. All right.
Hi, Benito.
Is that better?
Yeah,
Yeah.
we just see the
Cool.
PowerPoint.
All right, cool. So thank you everybody for joining today, our webinar on how to deal with unpredictable lead times. This is a very hot topic, as we all know. In fact, NetStock did a webinar with Nicholas, about a month or so ago, maybe a little over a month ago. And this was a repeated question that we got a lot of engagement around. And we said, hey, why don't we put together some content specific to this and get a variety of inputs here. So I'm excited about the session today. I'm hoping everybody comes away with some good learning to apply into their business. So a little housekeeping, we will have polls throughout the webinar. So get ready to be interactive, and we also be monitoring the Q&A, and we will get to those questions at the end of the session. We have about 40 minutes of core content, and then we'll open up for Q&A. All right, for the agenda for today, we are going to be covering lead time variability across the supply chain and ways to mitigate the lead time variability by increasing predictability. And we will take a lens on that through Jan, which I will introduce here in a second, from more of a business and retail lens. And then Nicholas is going to take a data science lens and discuss how lead times impact your inventory levels, why you should measure supplier performance, how to evaluate lead times, practical steps to reduce and stabilize lead times. And again, through that data science lens. So now for me to go through, introduce our speakers. Jan Tukker is the founder of BusinessChain, a supply chain advisory business in Cape Town, South Africa. He has extensive experience in a variety of industries, including pharmaceuticals, manufacturing, and retail. He has earned a variety of qualifications we all should be jealous of as well. And Nicholas Vanderput is the founder of the supply chain consultancy Subchains. He also co-founded SKU Science, a demand forecasting platform. And he also has 2 books on the science behind forecasting, and those can be found on Amazon and other chains as well. In fact, Nicholas, we haven't even told you this. We bought some of those for some of our customers as a thank you for some stuff. So we're customers as well. So, and with that, I will pass it over to Jan to get into the core content here.
Thank you, Josh. Let me just get my slides up. All right, can you see that slide?
Yeah, that's perfect.
Okay, thanks, Naja, for getting the poll up. So we're going to get a poll question out now, and then we'll get some feedback. I see you've put both of them up, Naja. So do they need to answer both questions? Naja?
No, Nick. No, I'm sorry, Jan. Just the first question.
Oh, okay. So yeah, as you're answering that question, just a bit of background. I'm going to cover a business perspective of lead time variability across the supply chain, and once we've got the feedback from the questions and the results, I'll try and infuse some of that information into this presentation. There we go. So the answers I'm seeing is that suppliers, I see a lot of people answered both. So let's look at the first one. The question was, which leg of the supply chain has the most variability? And the dominant answer there was suppliers. So just dealing with suppliers and issues around supply of product. The planning variability and transportation variability came out second, and then sort of last was distribution, which is no surprise. So I'm going to hide those results and come back to the second set of results just now. That's okay, Naja? She must be on mute. Okay, I'll continue.
I just ended that one, Jan, sorry.
Okay, so has everybody voted? Can I carry on?
Yep, you can carry on now.
All right, thank you. So it isn't a surprise to me that distribution was the least volatile or variable, and that'll come through in the presentation now. So just in terms of lead time variability across the supply chain, if you just picture the supply chain of all those elements across the top of the slide, from planning your supply chain, which takes time itself, then thinking about your supplier's supplier and their supply chains into your supplier's lead time and processes, then your supplier having to get stock to the port. So I've used an example of an imported product, which is quite common, but I'm sure there's lots of different supply chains. So I'll just use a generic one, which is an imported supply chain into a local distribution center and then into stores. So the supplier then delivers to their port of dispatch, or the origin port, which is a process itself. Then stock gets shipped across the oceans from port to port. Then it arrives at the destination port of your country. Then it gets taken to the distribution center, where it gets stored, picked and packed, and then transported to a store or a mall or your customer, and then made shelf ready. So there's a variety of concepts there, but supply chain variability is impacted, and lead time is impacted across every single one of those elements. So each element affects the overall lead time. So in terms of safety stock to buffer against unpredictability, So too much safety stock is being conservative, and that's costly in terms of capital holding costs. And too little safety stock, being aggressive on your safety stock, is costly through out of stock situations. So there's a real fine balance. Science helps a lot to manage these processes, but there are a lot of soft skills and relational processes one can follow to reduce the variability. Each industry is also somewhat unique in creating supply chain reliability. So comparing the semiconductor or oil or fashion industries is quite different. And then, which is very topical at the moment, is that the political and economic factors have a large impact. So each scenario needs careful consideration. So if you know you're sourcing from a country that is going to be impacted by an economic or political situation, you might want to buffer up on those elements. And I have no doubt that almost everybody on this call would have felt some need to react to what had happened at COVID and what's happening in Europe at the moment. So there's a lot of other elements that outside of our control that we need to consider to reduce lead time variability. So planning actually is a subset or foundation that helps execute all of the above elements from your supplier to shelf ready. So I'm going to give you some general comments, and then I'm going to talk through each of those legs with some suggestions on how you can reduce the variability. But without a doubt, comprehensive measurement of each node is required. So if you really are dependent on your supplier to make your supply reliable, and that was the highest element that came out in terms of variability, then it's in your interests to make sure that your supplier is following the correct methodology of delivering ingredients or raw materials to your supplier in time to make sure that your supplier isn't affected. And sometimes that means that you as the end consumer or company needs to get involved with that leg, but not always. Your supplier should also always be held accountable for the end delivery, but just helping them go one step back really does help. Then a very good understanding of each node's limitations, its capacities and challenges is critical. So if you know that a port in Shanghai, Ningbo, wherever it is going through a repair process, or they've had a storm, or there's a delay, knowing this information helps you work around those issues. So it is quite dynamic. Then short lead times are very attractive. Everybody wants short lead times, although consistently reliable lead times keep supply chains running smoothly. So I would much prefer to have an extra day in my supply chain knowing that it's very reliable than to have an extra day one week and then have a week late the following week. And then last comment on this slide is that effective supply chains need constructive relationships, trust, and win-win mentalities. This is a very important element, because if you go into a negotiation where you think that you're going to dominate your supplier or your carrier or your 3PL distribution provider, and you want to be have the upper hand, then I fear that you might not get the result that you want. It has to be win-win. All the players in the supply chain need to make a profit and need to work together to make your customers get what they need. All right, going to the suppliers and the supplier. So again, this was the topic that came up as the most variable. So supplier reliability, if you want to improve the supplier reliability, you have to have a supplier conformance program measuring that reliability. If you don't have a program that measures it with penalties and rewards, and you can try either of them to see how they work. If you only try the rewards element, it would be interesting to see what the outcome is. If you only try penalties, then there's a negative relationship. So you need some sort of penalties and rewards. So if a supplier conforms very well, delivers on time, and does everything they need to do, they need to be rewarded for that with more work or recognition of some sort. So the things that you could measure in a supplier reliability program is on time and full, which is a very common measure, whether it's packaged correctly, so your downstream distribution center can send it on without too much rework. Make sure the quality is right. Make sure you've manufactured correctly and against plan. And then collaborate with the supplier to agree reliable measures. So this supply conformance program should be done in conjunction with supplier. Of course, if you are paying your supplier to deliver something and they've agreed to terms and conditions, you need to hold them accountable for that. And then if your supplier is consistently unreliable and you have capability, go and help them implement something like a Lean Six Sigma program, or something that can help them be reliable, or at least hold them accountable for improving their reliability. Then in terms of supplier outbound and inbound, this is more the cross-border legislative process. So that's the exporting product out of a country and importing it. So the export and the clearance. So it's quite important to know exactly what is going on there, because you will have delays at ports, whether there's, if the documents aren't correct, there'll be delays, and that'll affect you. Measure how many customs inspections there are and how many holdups there are, so you can understand what's causing the delays and going to remedy it, and make sure the tariff codes are correct so that they don't get held up unnecessarily, and then measure very clearly the lead time through each of those nodes, so that you can plan in your planning cycle for the correct time. And then in terms of the transport elements, so I have a statistical example here, but transport is often the longest lead time in the supply chain. So perhaps it's a good time, Nadia, to just bring up the results of the second poll that we sent out.
I can actually relaunch it again.
It's up to you. And I saw some people did vote. So maybe I'll relaunch the second question.
Okay.
And let's just get the results of that one, because that might lead quite nicely into this slide. So the question is quite similar to the first question. The first question was, which area of the supply chain causes the most variability? And it should link fairly closely with this one in terms of which is the most difficult to predict. So you might have transportation that's quite variable, but other areas that are more difficult to predict with accuracy. Do we have any results yet?
Yes, we're still getting some answers, 68, 69%. Okay, I'll end it here.
All right, so a little bit different then. So suppliers still came up quite high. It seems like that supplier engagement is a key element that's coming out. And so that supplier conformance program I spoke about is something that you must seriously consider. So suppliers and transportation came out high, and that also is no surprise to me, because transportation worldwide, and I would assume a lot of that might be shipping transportation, has been very volatile. So those two elements are not a surprise to me. Okay, great, thanks. Let's carry on then. I'll close that on my side. So transport reliability. So often it's the longest lead time in the supply chain, and clearly it's difficult to predict, especially now. So what I would do and suggest is that always plan in your lead times, as in your planning cycle, to a reliability or a confidence percentage. So how confident you want to be that stock arrives where it's supposed to within the time that you've allowed. When you do this analysis and you've got 100 examples of ships leaving Ningbo and arriving in San Francisco, and of those 100, you've got a couple of outliers that are just, I don't know, something happened, they were really badly delayed. you need to take those outliers out statistically. Once you've got those outliers out, you use the averages within the remaining set of numbers. So you might only have 90 left of the 100 examples. And then you need to aim at a confidence. So say if you want to be 97.7% reliable statistically, that happens to equate to, on the left-hand side, not getting too technical here, but it's 2 standard deviations. So you take your mean and you add 2 standard deviations, and that equation there will equate to being 97.7% accurate. So as an example, to just illustrate it a bit, if you were a planning department and you used a shipping lead time of 6 weeks, for example, or 42 days, which just happened to be one of the worst cases, and planning departments don't like to be late, so they generally are a bit conservative. I sense there's a couple of people smiling out there. The actuals, and this is an actual example that I had, the actual results may average 25 days with only a 2.5 day standard deviation. So taking 25 days plus 2 standard deviations gives you 30 days. So you could reliably plan for 30 days of transportation instead of 42, saving yourself 12 days and being 97.7% accurate, which is a very high level of accuracy. So I think some science and statistics is needed in this particular case, especially since there are long lead times and they can affect you. And then try not to then react to when something doesn't make the 30 days, because there will be times where it'll be 31, 32, 33 days, but those should be outliers. Okay, moving on to the distribution element, which you all said was the least variable, which I think is correct. It's often the element with the least variability, and often it's an internal process which a company owns. And the main factor here is staffing productivity, which can be improved through incentives. But the measurements at the distribution element is to measure units per man hour, make sure that there is a good understanding of how many units can be processed through a particular distribution center, and that you plan for that particular time in terms of lead time. And that's lead time from receiving to dispatch. And the other thing is to make it very visible within a distribution center, to make sure that the people in the distribution center know that they are ahead or on track or behind schedule. Couple of slides left. The delivery element in this slide, I focused on delivery to people's homes for omni-channel more specifically, because that's such a hot topic. So lead times to online customers, I have no doubt almost everybody on this call will have some experience in letting customers down because lead times weren't correctly managed, or bumps along the way weren't correctly managed. So make sure the reliability is higher on the courier selection scorecard than cost. And cost is often the number one priority selection tool to select a courier. Reliability needs to be a lot higher to make sure that you can not upset your customers. Open relationships with couriers is very important, although not that common. So if you can have an open relationship with your courier, where you really are honest with each other around what's happened, you can then mitigate issues and remedy them. The other thing the other process which really works well is to use an aggregator, where it's a company that links with lots of carriers, and you would connect with that aggregator and they would select the best courier for a certain delivery to a certain region, where those couriers are the best in that particular region. And that supports the last comment. So use couriers in regions who have shown strong reliability and speed capabilities in that region. There's no doubt couriers can't be the best in every single region. And then finally, shelf ready. Really 2 comments here. On-shelf availability is such an important metric and should be measured at the endpoint, and predictive analytics can help for the final leg. And the closer you get to the customer, the more intense the interaction is, because you could be upsetting customers. Prior to that, customers are The internal customers are part of the process, not the actual customer. Okay, and then just in final considerations, my last slide, the use of artificial intelligence across supply chains is making a real difference. With so many stock keeping units to manage, the processes are often not suitable or capable of understanding every stock keeping unit and store or endpoint location combination. It can end up into millions of parameters or decision variables, which is near impossible for a person to do. So artificial intelligence is something that should seriously be considered. Also, what I've infused through this discussion is an integrated supply chain is really important. So, your customer buying behavior and demand can be supported through an integrated supply chain, right through from your supplier through to your own stores or your customer direct. Then a pull supply chain is much more beneficial to a push. So that means the customer is pulling, or the supply chain is driven by your customer demand, not by you pushing stock to stores. So wherever possible, use a system or process that helps your customer. So react to customer. So although some industries do lean towards one of these, for example, fashion companies generally create demand, so they will push stock to stores, but there is an element of reaction thereafter based on sales. And then groceries is generally a pull. So you know how many bits of food you're going to sell, and there is a more reliability in that process. So it's really demand driven. Then listen to the data, and I have no doubt that Nicholas is going to be very supportive of this too. Your data will tell you a lot of things. Listen to it. Sometimes people don't want to listen to the data, and therefore they add lead time buffers in. But if the data speaks volumes, really rely on the data. And the last two elements is really acknowledge the people element when collaborating. Lead times can be highly impacted by the relationships you have with your partners. And then without doubt, adopt a continuous improvement mindset, where for every one of those elements, there's always something you can improve. So have a capability within your organization that allows for continuous improvement. And that's me. Thank you very much.
Perfect. Julian, I think I will take over from now and share my screen. Just let me know if you can see it. Just a second. Should be fine. Hello, everyone. So it was a pleasure listening to Jan's part. Now I would like to share with you a few thoughts on these lead time and how to deal with these long, variable, unpredictable lead time. So for those who know me, you know that I'm a very quantitative person. I like to look at data. I like to use machine learning to forecast demand, for example. So here I'm going to have a bit of a mix between this data-driven quantitative approach and a mix of how can we solve this with human, with communication and process. Basically, what we're going to do is we're going to discuss how do we model these lead times and how we do manage inventory and demand with these lead time, first part. Then we're going to see that actually what we need to talk about is how do we evaluate these lead time, how do we measure them, and finally we're going to discuss, okay, that's nice, but how can I improve the situation, the status quo, by reducing my lead times and stabilizing these lead times. And this is a bit of the part of this presentation that's really aligned with the one from Jan. Let me start with this. I really like this scenario, and I'm going to start from this one. So let's imagine we are all working in a bakery and we are baking cakes. And we ask ourselves the question, how many of these delicious cakes do I need to bake? If you follow me on LinkedIn, on Medium, or read my book, you know that I always start from this very simple example, and I just love it. And I always come up with different pictures, by the way. Okay, so let's imagine we want to know how many of these cakes we need to bake. Basically, the information we have is that the demand for cakes every day is from 1 to 6. Okay, let's just imagine that on a typical day, you can sell from 1 to 6 of these cakes. Well, if you have to model this, basically it's like rolling a die. You roll a die and you can see it on the slide here, you get a 1. It means that on this day you just sold 1 cake, but you could roll another die tomorrow and get to, I don't know, 3 cakes, right? So basically demand distribution here is pretty flat, and it's pretty easy to make an inventory model that would tell you how many of these cakes you need to bake to achieve a certain service level, right? It's a very, I would say, simple situation. Now you're looking at this and you might be thinking, well, Nicolas, thank you so much for this example, but my supply chain, the lead time is not just 1 day, and it's much longer than that, and it's variable, or maybe it's even unpredictable. So we need to come up with another example. Let's imagine now that you are in charge of a supermarket, and in this supermarket, you're selling different types of cakes, but you don't bake these cakes yourself. You need to buy them from this local bakery we mentioned earlier. Now, the issue with this local bakery is that basically it's not always right on time. Actually, you need to wait a certain amount of time to get these cakes. Let's imagine that as the supermarket responsible, when you do an order to this bakery, you need to wait from 1 to 6 days before you get these cakes, okay? So you need to wait for some days to get the cakes, and on top of that, demand is variable as well. Now we get 2 things that are variable. Demand, cake demand, so every day you get different amount of demand, but also lead times. Actually, again, we can express this by just throwing dice. So basically, on the left side, you see you need to roll a first die, and that's the lead time. It goes from 1 to 6 days. And then based on this lead time, so here I just roll a 6, you need to roll some more dice to know basically what was the demand during this lead time. So here we know that it's going to take 6 days for us to get the cakes. And then we can ask ourselves the question, but what was the demand over these 6 days? In this example, it would be 21 units of cakes, right? Now, before I show you the graph, you can start to think of what's the demand distribution over this random lead time. So some of you might think, okay, it looks like a normal curve or something, or maybe you think it's flat, or maybe you think it has a crazy shape. I actually had to run millions of simulations to come up with the graph on the right side, because this is the demand distribution you're going to face over this random lead time. Just take a minute to see how not normal and chaotic and strange it is, but that's basically the demand distribution over the lead time. So it means that if you are in this situation where you think, okay, every day I have some random demand for cakes, and when I do an order, I get a variable lead times, and I need to protect myself to keep safety stock against this lead time. Basically, you need to analyze, and that's something that I'm really trying to explain in my book. If you're interested in inventory optimization, you can always try to find it online. There is no shortage of this book currently. I'm quite glad about it. Okay, back to this demand. So basically you have this demand curve over the lead time, and you want to have safety stock. You want to be protected against that. And still, it might be a bit complicated, but we could do a model that would say, well, if you want to have a fill rate of 95%, you will need to bake that many cakes. You will need to buy that many cakes in advance. So even though it's complicated to deal with this very strange distribution, we can still deal with it. We can make a model that will be able to deal with it. Now, it's all nice, but there is an issue and we need to solve it. Before we do that, I have a question for you, and the question is live right now, is do you have this kind of very long variable lead time, or do you still enjoy some very stable lead time? So please take a second to look at the poll and answer these questions. I guess most of you deal with some variable and predictable lead times, but it's still going to be interesting to see where you stand. Naja, maybe we could see the answer now. Perfect, thank you. So only one of you has a stable, known, predictable supply chain. So congrats to you. We all wish we were working in your company. But for the rest of the team, we have most of you partially and predictable lead times, but not so much. But we still have a third of you that say, well, it's quite often variable. And I also included another one that says, most of the time it's stable, but from time to time we have some unpredictable delay, and then we have a massive impact. I guess this is really the worst, where most of the time everything's fine, and then at once you have this kind of shipment is lost, and the supplier is totally late, or the supplier is out of stock, or goes bankrupt, or you have a war or COVID or anything, and then you get a massive impact. Okay, again, All of this can be modelized into an inventory optimization software and inventory optimization model, and it would be fine. Now, as said, this slide is very nice. I really love it, but there is an issue here. There is something that's missing, or at least there's an assumption here that's very, very important. Let me show you the drawback of this. Basically, for this thing to work here, we assume that we know how the lead time behaves. We assume that we exactly know that when you make an order, lead time could be 1 day, 2 days, 3 days, up to 6 days. We know this. So basically, we tell the model, we know that the lead time might be variable, but we exactly know how it's going to behave. I think that in practice, most of you do not exactly know how the lead time from your supplier is going to behave. You might think, well, maybe it's going to take 5 days, but could also be 7 days, 10 days, 15 days. And it's kind of very difficult to allocate a probability to that. So actually, for such a model to work, we need to work first on gathering data about lead times to be sure that we can properly estimate them. Let me move on to then the second question of how do we estimate lead times? There are two things that we need to pay attention to. What's the expected average lead time and how reliable the thing is. Let me show you a comparison of these two. So expectation would be to say, well, lead time will be 3 days and a half in average, but in reality, it's like throwing a die, right? So if you're at the supermarket would ask to the bakery, what's your expected lead time? The baker would say, well, it's 3 days and a half. But if you create a model using 3 days and a half as a lead time, it would be totally wrong, because actually the lead time could be 1 day, but it could also be 6 days. And this makes a huge difference. So how do we assess this expected lead time and this reliability? Well, we have two major sources of information. The first one would be really the contract that you sign with your supplier, the service level agreement, these kind of things. So the first step would be to look at the contract, look at the service level agreement or these kind of things to see there what's the expected lead time I can get from my supplier. The second thing would be more, I would say, data or analytics driven, and it would be, let's compare for each order you made to your supplier, the ETA, sorry for my French, so the estimated time of arrival versus what's the real lead time that we got. And by comparing these two, you will see, did we get something reliable from the supplier? Can I trust the supplier when I make an order and they say, okay, it's going to be delivered in 2 weeks? Can I really trust this, right? So basically the question is, did they deliver in time, in full, what they promised? Now you need to get to a kind of analysis where you say, when they promise 2 weeks, I know that this is the distribution of what could possibly happen. I have a very good illustration of that, and I got it directly from NetStock software. And here you see where, when I do an analysis of lead time performance for a certain supplier, in average, I'm here, but then from time to time they're late, and from time to time they're late by this much. And actually from time to time they're also early, okay? So you need to do this kind of lead time analysis for each supplier to assess, well, when they promise something, are they gonna get exactly when they promised, or are they gonna get delayed or too early? Again, in terms of model, I'm gonna go back here. The objective is to get to this kind of demand distribution over the lead time, okay? As soon as we have this, we can solve it and we can tell you, well, if you want a fill rate of 99% and 95%, this is how much inventory you need. Okay, so that's for the evaluation and the model. Two more comments here. Actually, it's not so easy to evaluate these lead times. You have two things that might complicate the task. First, pre-orders. As soon as you're dealing with pre-orders, the lead time, you cannot really assess it by comparing the time you made the pre-order and when you got delivered, because basically you could do these pre-orders 6 months ahead, and this is not a real lead time. On the other side, you have this self-censorship, which is really awful. So basically, in most supply chain, if you know that your supplier has a shortage, you're not going to make an order. Instead, you're going to order something different. You're going to find another supplier, or maybe you're just going to wait. As you do this, you face an issue, is that basically the system will not track the fact that the supplier was late. So you will only include in the system the cases where the supplier didn't have any shortage and could deliver you the goods. So you're censoring all the worst case from your data set by default. So this is kind of an issue that you will need to deal with if you really want to track these lead times. Okay, let's move on to the last part. So we discussed the model, we discussed how to get the data about this lead time. Now let's try to move on to how do we improve the situation. I have two main ideas here. improving collaboration, and then improving logistic. And I'm here totally aligned with most of the cases that Jan highlighted. The first thing that I would advise you to do, and I'm advising this because it's so easy and it's matching so many supply chain, you can really do that for most supply chain, is to talk and to share information with your supplier. So you can, for example, ask your suppliers to talk about their production constraint, shipping constraint, or any random event that's happening. By communicating on this openly, you will be able to plan properly your supply chain and your orders. Now, most of you, and I'm discussing with a lot of companies during my training courses, sessions, and coaching, are always sighing and wishing that their client would give them more information about their demand, orders, and so on. Remember that it's great to get information from your client, but you also are the client of someone else, right? So, and I forgot the question here. Let's move back to this question before I discuss this. I'm back one slide. So here, just to see what kind of information you have. Thank you, Naja, for the question. Can you answer the question? So I'm asking, what kind of information do you have about this lead time? Do you have this contract? Do you have historical data? Or, well, you don't have data and you just guess that the lead time is, I don't know, 1 month, 2 months. Let's just take a minute here. And I know I'm a bit beyond the normal time. Naja, can you show us the answers? Yeah, great. Perfect. I see that only 12% of you don't have data. That's quite good. I'm really sorry for those who don't have data. It might be a good time to start looking for that. And I see that 2/3 of you are tracking historical lead times and delays. That's amazing. That's perfect. That's really, really great. So for those of you tracking these, just really pay attention to pre-orders and self-censorship. I would really be sure, if you have one outcome for this webinar, to check when you do that, how do you deal with this self-censorship when your supplier is out of stock? Back to my collaboration, the main point here is also to say that you can share information to your supplier. We are always the client of someone else in the supply chain. So you can share with your supplier your own demand forecast. You can share your own inventory level. You can share your supply plans. You can share the orders you think you're going to do in 6 months. You can share so much information with your supplier. You can do this for free. You can just send them an email with the information, and this might help your supplier quite a lot. Now, there is something, it's a bit out of scope for this webinar, but I absolutely want to mention it because it's so important. You want to avoid at all costs that your supplier is doing order from forecasting from what you do, because this will result in bullwhip. If you're not familiar with order forecasting, let me just try to explain that in a second. Order forecasting means that your supplier is not forecasting the real demand you're facing. Your supplier is kind of double guessing how much you're going to order, right? So if you change your ordering policy by saying instead of doing an order once a week to once a month, or you're saying I want to have 2 months of stock instead of 1 month of stock, this is going to have massive impacts and effects on the order you're going to do to your supplier. Now, you don't want your supplier to do some double guessing on what you're doing. Instead, you want to share with them your supply plan, your demand forecast, so the supplier really understand what's going on for you, and they can plan in the future how much to produce for you. So please avoid order forecasting, share information with your supplier. Now, beyond this communication, you can do something else, logistical excellence, and we already mentioned some of that. One of the ideas that you could do is to implement these fixed lanes where you're really going to pre-book a truck, a boat, a plane, whatever, every month or every week at the very specific same hour or day. For example, you could book a very specific time slot with your supplier saying, well, at Monday, 10 a.m., no matter what, you're going to send us a truck, and every week we're just going to decide what we put in this truck. Well, it's not a silver bullet. It's also come with some drawbacks. For example, at times you might just need more than a truck, but it also means that from time to time you will only ship half a full truck, which is definitely not optimal. You can also plan for emergency shipments, saying that, well, if I'm too low on my inventory level, I can get an alert from my inventory system and right away book a plane with the goods I need. Let me finish with and conclude with this slide. On the left side, I have to say that, and it's a bit out of scope of the subject of just modern safety stock, we also need to talk about risk management. You need to try to foresee, plan, and prevent this risk, and try to understand what are really the risks for me. Is it that my supplier is out of stock? Is it that I don't have the logistic capacity like boats that's going to block me, or is it an issue that maybe the product is discontinued or the supplier is out of business? Based on these risks, you can really start to think, what should I do about it? Putting more safety stock is not a silver bullet. Safety stock comes with drawbacks. So maybe it's not about putting more safety stock. Maybe it's about finding another supplier or a replacement product and so on. Finally, and this is a subject that's so important for me, is how do we use a software, an inventory management software that's going to basically help us in this line. We did a webinar a few weeks ago with NetStock that was amazing on inventory management software and the best practices for inventory planning. And we discussed something that I really liked. It was this alert-driven inventory management. What you want is that your inventory software is going to warn you that you are at risk for a very specific product. And this software can do that because the software knows who your supplier is, what's the lead time. If you update the lead time, the tool knows that you're now at risk based on your forecast and so on. You need a software to tell you that you are at risk so you can act now. That was the object of the previous webinar. Last point here, it's also very, very important that as we play with lead time, and as we know that lead time are good or bad, that we could reduce them, or maybe there is an issue and you need to have longer lead time and so on, you need to have an inventory model that takes this into account. The worst of the worst is that you spend so much time trying to analyze that the lead time is a month and a half, and then you cannot do anything with it because your inventory model just doesn't take lead time into account, right? So you need to have an inventory model that you can update easily that will take into account these lead times. For example, if you manage to reduce these lead times, that's great, but you also need your inventory management tool to reduce the stock target. Otherwise, you just end up with too much safety stock, and we don't want this. So basically, to conclude this thing on inventory management, you need to act before it's too late, and you need an inventory management tool that's going to warn you about the future. Now, to conclude this small presentation, I have a question for you. And if you came to my webinar in the past, you know that I really like this kind of last question. I'm asking you, what's the next step for you? And what's the thing that you want to do after listening to this presentation? And you always have the answer, I'm fine, thanks, Nicola.
It's almost a pity, Nicholas, that you can't select more than one of those items, because I'm sure some of the people on the call will have multiple issues.
Yeah. Najah, let's maybe see the answer and then we can move on to Q&A. Great. So we see that most of you are saying that there is an issue with assessing suppliers' lead time. This is not an easy topic, and I'm glad I could at least show you how important it is and how difficult it is to get that and how it's driving your inventory model. Some of you say improve the way I communicate with my supplier. I'm glad I could convince you, and this is an important message for me, that we are always the client of someone else. And you can share information for free, even if it's just an email that you send once a month with your supply plan. I think it could help you so much. Okay, thank you, everyone. Josh?
Yes, thank you, Nicolas. Thank you, Jan. Interesting stuff with the polls as well. So give me 1 second. I'm gonna share one last thing. So, all right. We had just talked about some really practical things and around lead times and how to measure that. And, you know, NetStock is hosting the webinar, and want to give you our perspective on this as well. So what we find is many times people are trying to organize their internal supply chain data through the ERP data. And many times that ERP isn't able to do the forecasting or supplier risk that they're looking for. So they end up putting this into a spreadsheet, and that's ripe for error. And just the amount of variables that go in is very hard to track. So NetStock indeed can help with supplier lead times, and you know, just organizes the suppliers and the raw good lead times. And we absolutely have a model to monitor supplier risk and automatically give order recommendations based on that risk profile. And multiple, Nicolas had talked about this, but that feedback loop to your suppliers to get them ahead of it really increases their ability to execute and get you, the lead time as stated. So having a tool that allows you to do this and automatically does this to allow you to be more proactive is very important, and is something that's very approachable for up and coming organizations like maybe the one that you're in today. So with that, we'll flip over to Q&A, and I'm happy to take questions. Let me get the chat open here. I could either take Q&A. All right, here's one question. So either go into the chat or the Q&A, and if you have some questions, I can ask our speakers. We've got about 10 minutes that we can put them in, and we'll try to get to all the answers. If we don't, we'll email them out. So this is specific to an industry, but what would be the best inventory turnaround in the airline industry?
I can jump in there. I don't have the answer, but I did see something on Emirates Airlines that actually do a lot of maintenance of spare parts or storage of spare parts for many airlines across the world. And I saw something on YouTube, perhaps Google it. The Emirates, I'm not quite sure what you would Google, but Emirates airline parts process. And they were very impressive. It was a matter of minutes or hours that they can get parts, and airlines would fly in, get repaired, and fly out.
Thank you, Jan. A general question that we got, what's a good way to even approach using machine learning or AI? Those are big words. We hear it, it's a buzzword out there. How does that get down to the practical level, and how do organizations best use that?
So artificial intelligence and machine learning are fascinating topics, but there aren't many companies that have really embraced it yet. So marketing and the media will make you think that everybody's using it, but it's not that prevalent yet. But two good examples of artificial intelligence is if you have to allocate product from your distribution center to your stores, and it's a very reliable process where you're selling commodities or something that's got a very reliable demand pattern, and baked beans is always a good example, then you can use great tools to do that, although artificial intelligence is not going to be that useful in that state. If you're allocating fashionable product to stores based on very little history, it needs to have connected this particular product to a similar type of product and made a whole lot of assumptions around where that product should go. And machine learning and artificial intelligence uses that data to predict the future, which is much better than a human being doing it. So that's one example. And the second one is artificial intelligence is in your Google Maps app. It'll work out where you should drive and which is the quickest route. And couriers, DHL and all the big courier companies and smaller courier companies use machine learning and artificial intelligence to work out the best route to drop off the multiple parcels, which in some cases can run into millions of different variable options.
We have another question here. Maybe we'll start with you, Nicholas, on this one, but how do you deal with two lead times for one product? So one where a product made in batch is in stock and the lead time is very low, as well as one where when it's not in stock, it needs to be made in batch and the lead time is very, very high.
Well, it's quite of a complicated case. And I guess that if you're dealing with such a case, with such an extreme case, I would discuss more the collaboration with your supplier concerning inventory level. If it's internal, then I would definitely deal with it using some very different inventory models. So let's imagine it's an internal problem where you have a few warehouses close to your client and you have a production plan. And if the production plan has some inventory, it just takes a few days to ship it to the warehouse. But if this manufacturing plan doesn't have any inventory, then it might take you 2 months to produce it again. In such a case, you have a family of models that can help you out. It's called multi-echelon inventory optimization. It's quite advanced, but it works really, really well and it might help you in this case to know how much safety stock you need to keep and where to put it. Because the whole question is, do you need to keep safety stock at the production plant, or do you need to keep it locally? Now, if you have this kind of issue with your supplier, it would, I think, be very harmful for you to keep a safety stock against this 2-month lead time. And then I guess that you're left with, you need to analyze what's the real lead time, why the supplier would be out of stock or not. Can you do some pre-orders? Can you share information with your supplier, as I mentioned? But unfortunately, it's kind of difficult to give a very general answer to this.
All right, and thank you. And one more here is, what inventory distributions do you find in common practice across industries?
Well, concerning this distribution, and I think if the question is what kind of demand distribution do you see, I'm not really sure I get it, but I see that most industry follow some normal approximation and assumption, and most software do that, whereas in practice, nothing is normal, like absolutely nothing is normal. You saw it with the graph I show you. It doesn't really look normal. And if you use a normal load to that, you might face some issues, especially as your lead time is variable. The more variable your lead time is, the more you need to get away from that. So what I see now is that more and more models use very custom distribution. And it's not just about the distribution of demand, but actually it's about the distribution of the forecast error. And I think it's a very common mistake that a lot of people do, looking at how demand behaves, how demand is distributed, whereas actually what you might need to do is to look at how forecast error is distributed. And that makes much more sense.
All right. Well, what we will do is, if there is any questions we didn't get to, we will work with the speakers to get some answers, but we're about up at time. So thank you everybody for joining the webinar today. You can see some quick links on the screen right here. Connect with the speakers, connect with us at LinkedIn or at Netstock, either through LinkedIn or our website. And you'll see an email from us for the recorded version, along with some takeaways, and you'll be able to watch or watch pieces if you'd like. So we'll be continuing to do these webinars with great leaders in the industry like Jan and Nicolas. So thank you very much for your time today. Thank you everybody for joining and spending a bit of your day with us, and we look forward to next time. Take care.